Hello and welcome to this session, Learning Outcome LO1. Understand mechanics today, we will learn how objects move and why they behave the way they do. Mechanics, a branch of physics, explores these questions by studying motion, forces, and energy. This video introduces the fundamentals of mechanics, from kinematics to dynamics, and the laws that govern them. Mechanics is the branch of physics dealing with motion, forces, and energy. It explains how and why objects move and the effects of forces on them. Mechanics is divided into kinematics, dynamics, and statics. Kinematics studies motion without considering its causes. Dynamics focuses on motion resulting from forces, while statics examines objects at rest. Kinematics explores how objects move. It involves concepts like distance, displacement, speed, and velocity. Distance is the total path traveled, while displacement is the straight line change in position. Speed measures distance per unit time, and velocity adds direction. Acceleration is the rate of change of velocity, including speeding up, slowing down, or changing direction. Dynamics explains why motion changes. Newton's laws of motion are fundamental here. The first law states an object remains at rest or in uniform motion unless acted upon by a force. The second law links force to mass and acceleration. The third law asserts every action has an equal and opposite reaction. Mechanics covers how forces transfer energy. Work done is force multiplied by distance moved in the force's direction. Kinetic energy is half the mass times velocity squared. Gravitational potential energy is mass times gravity times height. Power is the rate of doing work or transferring energy. Momentum links mass and velocity. The conservation of momentum principle states total momentum before an interaction equals total momentum after, if no external forces act. This principle is used to analyze collisions, explosions, and recoil situations. Momentum is mass times velocity. Understanding momentum is crucial for studying motion. Statics deals with objects at rest and in equilibrium. For an object in equilibrium, the resultant force equals zero. Similarly, the resultant moment equals zero. This concept applies to balanced forces, levers, beams, and structures. Understanding moments, the turning effect of a force, is essential in statics. Work is done when a force causes an object to move. It is the product of displacement and the force component in the motion's direction. Work is measured in joules. It can also be seen as energy transfer. Examples include lifting a load or braking a vehicle. Mechanics involves various energy types. Kinetic energy is the energy of motion. Gravitational potential energy is due to height. Elastic potential energy is stored in stretched or compressed materials. Thermal energy arises from heating, often due to friction. Electrical energy can convert into mechanical energy. The work done by a resultant force equals the change in kinetic energy. This relationship links forces directly to motion. It's useful when acceleration is caused by a force over a distance. Power is the rate at which work is done. It measures energy transfer speed. Energy cannot be created or destroyed, only transferred or transformed. Total energy before an event equals total energy after. Examples include ramps and pendulums. In ramps, gravitational potential energy converts to kinetic energy. In pendulums, energy continuously transfers between potential and kinetic forms. Suvat equations describe motion with constant acceleration. Symbols include displacement, initial and final velocity, acceleration, and time. Core equations relate these variables. They help analyze motion in one or two dimensions. Examples include free fall and projectile motion. In one-dimensional motion, Suvat equations simplify analysis. Free fall is a common example, ignoring air resistance. Acceleration is due to gravity. The final velocity squared equals 2 times gravity times height. This links Suvat equations with energy principles. Projectile motion splits into horizontal and vertical components. Horizontal motion has constant velocity. Vertical motion has constant acceleration due to gravity. Maximum height occurs when vertical velocity is 0. The range is horizontal velocity times time. Work is force times distance moved in the force's direction. Kinetic energy is half mass times velocity squared. Gravitational potential energy is mass times gravity times height. Power is work divided by time. These concepts apply to real-world scenarios. In mechanics, energy conservation is crucial. Total energy before equals total energy after. Common setups include falling objects. Ignoring air resistance, gravitational potential energy converts to kinetic energy. Mass cancels out, simplifying calculations. Newton's first law states velocity remains constant if resultant force is 0. The second law links force to acceleration. The third law involves action-reaction pairs. Work-energy principle connects work done to change in kinetic energy. These principles are vital for understanding motion. Calculate work using force and displacement. Kinetic energy depends on mass and velocity. Gravitational potential energy relates to height. Power measures energy transfer rate. Conservation of energy helps solve motion problems. Suvat equations apply when acceleration is constant. Symbols include displacement, initial and final velocity, acceleration, and time. Choose the right equation for known and unknown variables. Substitute values. Rearrange and solve. Check for realistic results. A moment is the turning effect of a force about a pivot. It's calculated as force times perpendicular distance. Clockwise and anti-clockwise moments balance in equilibrium. The principle of moments ensures stability. Apply these concepts to analyze structures. In conclusion, mechanics provides a fundamental foundation for understanding motion and forces. Through the study of kinematics, dynamics, and statics, we learn how and why objects move. Mastering these principles equips us with the skills needed to analyze and solve real-world physics problems effectively. For any inquiries, please contact us on WhatsApp at 074843616888. We appreciate your attention and look forward to the next session.